I didn't fool you. We're not doing a review video of an old nasty used parts chassis circuit board, but we are going to be coming back to this to do a little bit of testing of a soldering iron station. So this is a Dr. Meter soldering iron controller, and ouch, yeah, little critter. And the model is Si-48. So I've been getting, I wouldn't say swamped yet, but I'm getting close to starting to get, I get more emails than I can read already now, and I'm starting to now get a lot of emails from companies asking me if I want to review their products. Quite honestly, I ignore most of them. They're for products that I'm really not going to be needing, and I'm not going to do reviews on stuff that I don't use or I couldn't recommend. So when this company contacted me and asked me if I want to review the soldering iron station, I thought that's something I can review, because I'm going to be doing this basic electronics course here soon, and of course something you need to do any type of electronics repair is a soldering iron. It's kind of hard to install and remove parts without something to melt the solder. So a very important tool. Now, I started off probably like most people did. When you were a kid, you got the cheap little like Radio Shack iron. And then, you upgraded to a Weller. But it was a set temperature. So, basically a pencil iron that looks like this. But it was at a set temperature. And then you might have went up to an adjustable temperature station like this. And then, eventually you get up to the type of soldering irons I use nowadays are like Pace. The name's on here, actually. It's right there on the handle. Get the reflection right. Pace. But, my big Pace multi-process machine over there costs thousands of dollars with this hand piece, the desoldering hand piece, the hot air reflow hand pieces, the tweezers, the lap flow tools, thermopick. I mean, it's hand piece upon hand piece upon hand piece. But you're getting ultra, top of the line quality. Now, the main difference, these are both adjustable temperature. The main difference between something like this and something like this is, if you notice, this only has 2 wires going to it. This is basically, this cord looks just like the power cord, okay? So there's only 2 wires coming up to the actual heating element. So it's not temperature, it is adjustable, okay? There's a control on here. You set your temperature with. But, okay, right now, this sponge is damp. When I apply that, that's not going to tell the controller in here to send more power to this to heat the tip up. The tip temperature will start to drop. It is adjustable, but it's not compensating. These really expensive irons have, if you change the tip on one of the entire head heating element on one of these, you can see there's lots of terminals. You look down, if I can get the light right, or not. There you can just see, there's all the pins down in there. But the reason there are so many pins is because there's not only power lines coming up to the heating element here, there's also temperature sensors. So where this one just has a constant voltage, so that's actually all this is doing. This is controlling the amount of voltage that goes to that iron. This type of iron does not control the voltage. It sets a set voltage going to it. But when you first turn this on, the voltage is applied to it, full power. And then once it senses that it's reached its set temperature, it turns off, and it cycles on and off, on and off, on and off. But it precisely controls that tip temperature and holds it there. So, this is the top of the line. The bottom of the line is one that looks like this, but just plugs into a wall and has no temperature setting. Now you can have, I don't even know if I even have one of those around here anymore. I've got a bunch of the Weller, the blue WP, forget what the heck they are, WP65s, I think. Those, when you plug those into a wall, you'll actually hear click, 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 click. Those actually have a mechanical temperature switch inside. So once it gets up to a certain temperature, it makes and breaks a contact. It's basically doing kind of like the pace unit. It's applying power, taking it away, but there's no way of adjusting it in one of those. When you order those soldering irons, you order them knowing what the tip temperature is. This is adjustable. Like I say, you're just controlling the amount of voltage going to this tip. So I told, like I say, I'm going to be doing that course. I understand people can't afford uber expensive soldering iron stations. So I thought, what the heck? They're going to send it to me, no strings attached. That's one of the biggest things I do reviews. There's going to be no strings attached. And my review is what it is. If I find anything good, I'm going to let you know about it. If I don't like it, or find something I don't like, I'm going to tell you about it. So after I get done going over this iron, I'm actually going to tear this unit down, and we'll see what's actually inside this box. Is it truly temperature control, or how the adjustment is? Does have an illuminated on-off switch on the side there. Now, the first thing I actually wanted to check with this was, I actually don't have this plugged into a wall. I have this plugged into my BK Precision, or the BK Precision 1655 AC power supply, which is a variable isolation transformer and leakage tester. So there's pretty much always going to be leakage of some sort. Anything that plugs into a wall, metal parts on the outside, like even my test equipment here, there'll be some, it may be minute, but there's some AC leakage. It's just a fact of life and a fact of electronics. But I want to see, is there any leakage current present on this metal body here? So just so you can see on one picture, there's the isolation transformer. Here's the power cord plugged into the isolation transformer, and you can see that comes down to the soldering iron stand. So what we're going to do is, now there's, to focus on that button down there, I have it pressed in right now, it's on hot. The leakage scale is on the bottom. Anything, what you want to see is below 500 microamps, not milliamps, microamps. So we'll grab the leakage probe here, push the button, and the needle's not moving at all. Not seeing any leakage at all. That's a good thing. Switch over to the common. So what you're doing is you can actually check leakage at the hot and the common leads. There is a tiny deflection of the needle. I doubt you can see that on camera. The needle is probably moving a half of a needle width. That's not even worth writing home about. Which means safe. That's a good thing. As long as it's below 500 microamps, we're safe. Well, it's barely a needle width in movement, so that's good. So let's give this thing a try. Now, what does it come with? I wasn't going to show you unboxing. It's just a cardboard box. There's not much to something like this. Now, I did actually modify this sponge. First tried it. I didn't even think about it before I moistened it. I forgot to cut the hole in it. So Pace, I always preach about Pace equipment. Really expensive though. But their sponges, when you buy their sponges, they have a hole in the middle, where actually there's a knockout. The sponge is still in here, but you can push it out. It's like cut everywhere, but like the very corners. Most people leave it in. Actually, you should knock that out. That hole is actually very handy for cleaning your sponge. And I actually modify it then. I take a razor knife, and if you see, I actually back bevel that hole there. Reason being, these sponges normally come, actually, here's the piece I cut out of the middle, okay? They come like that. Well, you wipe your soldering iron off. Where's all the little solder balls end up with? On top of the sponge. Well, then the next time you go to wipe off the tip of your soldering iron, you're knocking all those little solder balls right off of the sponge all over your bench or rolling onto the floor. It's lead. Ideally, you should be trying to collect that. Actually, that's what I do with my solder. So, here's about a year's worth of desoldering right here. I collected it out of my my desoldering iron, and anytime I clean out my soldering iron stands from wiping, that's where it goes. There, all the solder goes into this little thing here for recycling. But yeah, little tip, just take a razor knife before, ideally you should do it, unlike me, I did it after I moistened it. Before you moisten it for the first time, because they come compressed, they're really thin, just take a razor knife, cut a rectangular hole out, but on one edge, back bevel it, like I did there. You can see it's back beveled a little bit. Like I say, it's kind of ratty because I tried to do it with a wet sponge, because I did it after I realized I should have done it first. The other thing is, because this isn't really deep right here, once you do, now if you just left it flat, it's fine, but once you put that in there, and the reason I do that is, that way when you wipe the tip, it shoots the solder down in here, and it acts as basically like a collection center. Okay, so when you wipe the sponge, or wipe the tip of your soldering iron off, all the solder and the solder dross that you're wiping off of your iron isn't landing on top, it's going down in that hole there. It gets trapped down in there, and it's not falling on your bench then. Only problem is, this isn't really deep. You can see there's not much of a lip here. So this is going to get just like that, a little tippy. So I might make this suggestion. What you could do is, when your sponge is brand new and dry, cut the hole out, back bevel the hole, put a dot of hot glue or silicone or anything, not the entire thing. You're going to have to at some point in time replace this sponge. But just put one little dot of glue like up here at the top, and then set the sponge in it. That will prevent it from doing that, from lifting up and out like that. I'll do that to this after this dries, because glue's not going to stick to it. It's wet right now. But that would be my suggestion. It does have a built-in little drawer here. There's no handle on it. You actually have to pick the base up to pull the drawer out. But it does have a man. That's the first time I've actually tried to open it. Ugh! Boy, that thing's, good Lord. Ugh! Need to be King Kong to pull that drawer out. But it does give you somewhere to put the accessory tips that come with it. Now, when I first saw, you see they look like they're white. They almost look like they're spray painted. And that's what I thought when I first saw them in the bag. And then I pulled them out of the bag and I was like, oh my God. These things are rough. You hear that? And that's like 160, 180 grit sandpaper, maybe even like 120. I mean, it's a really rough texture. But the tips are very nicely, and it's smooth up here, where it's actually tinned. So I don't know if this back part is either sandblasted. It almost looks like it's coated, because you see that, if I can get it in the camera, this one tip actually demonstrates it really well. Come on, camera, hocus pocus focus. You're not going to focus on this, are you? Come on. There we go. You see that little nip sticking out there? It's actually, it looks like, see that? I think they actually coat these with something. And like I say, I was like, man, what is this rough surface? Well, actually, I guess it kind of makes sense, because after I stuck this tip in here and tried, solder does not stick to that. Now, that's actually what you want. Now like my paste soldering irons, they come basically the same way. The tip, just this part of the tip, is pre-tinned. You out of focus again? Hocus pocus focus. This part of the tip comes pre-tinned, and this back here, the paste iron's kind of the same. They have a different coating on here. But it's meant so solder doesn't stick back here. Because the only place you want solder is the very tip. You're not trying to solder using this part of the iron. You're trying to do your soldering with just the tip. So, yeah, it's actually a surface coating, and it works. I mean, solder would not... I tried. Trust me. I just kept feeding... Ow, that's hot. Yes, it is plugged in and turned on. Yeah, I tried to get solder to stick. So I just grab some solder here. You can see it is plugged in and turned on. And you can melt solder back here, but it will not stick back here. It just balls up and falls right off. So that's, I guess, what that coating is. It's just meant to be a stick preventer, for a lack of better terms. I kind of like that. It's just I've never seen that type of coating on a soldering iron tip before. So it comes with 5 tips, 3 conicals, or round pointy tips, slightly different sizes. May not show up very good in the camera, but they are slightly different sizes. And it comes with a chisel tip, so double bevel chisel, and then one that's a fairly large footprint, single bevel tip. And that one actually, yeah, that's actually off a little big for doing, I was thinking maybe drag soldering, surface mount, but that tip's actually a little big for that. This double chisel tip would be fine for drag soldering. That's about the right size for doing some drag soldering. But, yeah, and this one would be good for, because that is a big honking tip, that'd be good for doing a bundle of wires, or if you're doing point-to-point wiring in old tube-type equipment, that one would be good for that. But I thought we'll give this thing a try. So that's what the circuit board was for. So let's see here. So what I've done is just desoldered most of the pins on this header connector right here, and we'll just try and resolder them. So let's assume this board had bad solder connections there. So what I always say, when you have bad solder connections, it's best to desolder them first. That way you're removing any contamination, oxidized solder, all the contaminants and everything, and you're starting off with a fairly clean surface then. Now when doing rework, I always like to add some extra flux. Yes, there is flux in the solder I'm using, but I always like to add just a little bit of extra liquid flux here. Because the whole key to having a good solder connection, as I often say, flux, flux, flux. Can't have enough flux. So we'll grab the soldering iron here, and you can see why I need to glue that sponge in. If you put the hole in it like that, it really needs to have be glued down. And we'll give her a try here. It seems to be working just fine. Not having any problem keeping up with little small terminals like this. But I've got the torture test set up for it. So, yes, it did terminals like that. Just your standard solder connections, did them just fine. Had absolutely no problem at all doing them. But I picked this board specifically because it has some huge ground planes. Okay, these big areas right here. And I have applied a bunch of solder right there. You see how thick that is? It's like that thick off of the board. Big blob of solder. Now I want to see what the thermal recovery is like on this thing. So I actually put that on there using my paste soldering iron. Let it cool off, and it's cold. Just to prove it, I'll even spray some isopropyl alcohol on there, and you can see. It's not going up in steam. It's room temperature. Dry that off now, actually. So, what I want to do is see how long does it take to melt that big, gigantic blob of solder. The tips act kind of as a reservoir for heat. Okay? And I was kind of nice to see these tips. You see how long that is? That's a lot of metal right there. So that has the potential, and we will see in a second, it has the potential to have fairly good thermal reserve, heat stored inside of here. So you've got the heating element, and you've got all of this metal in here that's hot. And as heat is being used at your tip, you have heat energy leaving the soldering iron, basically. There's thermal reserve stored back here that can then really quickly supply that temperature back out to the tip. So I just want to see if I can melt that huge blob of solder right there. So we'll wipe off the tip, make sure it's pre-tin, because anytime you try to solder, you always need to have some solder on there to make good thermal connection. And I'll set it on there, and I just left the temperature set to where I had it when I was doing the soldering over here, and I can see it's already starting to melt into it. And this is not the huge tip. This is just one of those little conical tips. It is the largest of the 3 conical tips that were included, but it is not that large chisel or single bevel tip. Yeah, actually, that's not doing bad. for a 40, whatever this was, 45 or 48 watt pencil iron. Now the top of it's all molten, but I can feel down through the puddle. The base of it's not completely molten yet. Almost there. And what I mean is it's molten the whole way down to the circuit board. And yes, it is now thoroughly, completely melted. So yeah, that's up there. You can see how it jiggles. There's a lot of solder there. So that actually wasn't bad. I didn't think it would actually do quite that well. Like I say, especially having a fairly fine tip like that. So if I had put this larger bevel tip in there, it probably would have been even faster. That's not bad. So I think from a practical user standpoint, it seems to work fine. Like I say, it's not temperature compensating. So as I did, that was a perfect example of what I mean by temperature compensating. When this soldering iron touches this solder down here, the tip temperature is dropping, dropping, dropping. It's not applying more voltage through this cord. It's just dropping. And when I pick it up, it's still the same voltage, but the temperature recovers. But it works fine. I think from a user's standpoint, it doesn't feel bad. The cord's a little stiff. It's normal zip cord. I can tell you exactly what this is. Just your normal 120 volt zip cord. So yeah, if you know what a lamp cord feels like, that's about the flexibility of the cord here. The hand piece, it's about standard size. It's a little rubber thing here. It's got a little hand protector. Oh, actually there's... Oh, I thought that was writing. It's not. It's just textured. But yeah, it does have a little no-slip grip thing there. Yeah, I think it feels okay. Now, granted, you have to realize I'm spoiled. I've been using, this one for years. But yeah, I think I could use this, not have any problem. So let me get that turned off. I'm actually going to let it cool down for a minute. And then what I'm going to do is I'm going to tear the base apart. So, because I'm not sure what they have in here for a voltage controller, because like I say, it's only got 2 wires, so it can't be a temperature compensating when it's just a variable voltage supply. I'm hoping it's not just a line cord going to a rheostat. We'll see if there's actually a circuit in there or not. But, so... yeah, I think it works. Seems to work fine. No big complaints. Like I say, drawer's it's a little stiff getting in and out. I think pulling it in and out. Actually, it seems to be loosening up already. Yeah, I think that's one of those. Just use it a few times. But yeah, you're not going to grab that. You're not going to put a little pull knob in there and gently pull that thing out. It's definitely in there to stay. But yeah. I think so far it's okay. Like I say, check leakage current at the tip, that's fine. So let me turn it off, let it cool off for a minute or two, tear it apart and see what the inside looks like. So I shall be back in a minute. I probably could have just done that on camera. It didn't take long other than to let this cool down. I just rewrapped the wires back up. But yeah, really all you got to do is pull these 4 rubber feet, actually push into these holes here. Just pull those 4 rubber feet out, and there's 4 screws down in those holes. You don't have to take these 2 out. That's just the panel that holds the cables or the wires in, and then this just slides back out of the way. So there is actually a circuit board in here. There's the on-off switch. Of course, it's got 3 wires because it is an illuminated switch. So let's... I think there's a set screw on there. No, so that should just pull off. Actually, it's one reason I have my fingernails. They're great for pulling knobs off. And looks like it's probably made in China, so probably 10 millimeter. Nope, it's not a 10. Let's try an 11. There we go. Kind of odd, because usually they're 10 millimeter. So, yeah, the housing, yeah, it seems okay. Decent thickness. It's not like it's paper thin plastic, so It's fairly rigid. Let's see, the first thing I want to check is, do they have the polarity right on this? Because yes, it's AC, but it is what you call polarized plug. So you have a narrow terminal and a wide terminal. Okay, the wide terminal is your neutral. The narrow pin's the hot. And let's see, they have the wide terminal is the side of the cord that has the ribs. See those little ribs right there. So what we want to see is, we should see the hot go to the switch, not to the circuit board. So, yes, that is the smooth side. So that's good. They got that right. So yeah, you don't want, what you should have, the power, the hot line should go to the switch. That way when the unit is turned off, the only place there's power is that the actual power cord and then to that terminal. And that's it. There's no power anywhere else in here. If you run the hot up to this board, then this entire board's hot the whole way back down to this switch. And the only thing that this is doing is switching the neutral on and off. So they got that right. What do we got here? Little transformer. There's a 0.01 microfarad. It's actually a X2 rated safety cap. It looks like they actually used actually MPX, I've seen that brand, so a name for, I don't know how high, ultra high quality, but a name brand bypass cap. There's a fairly large coil there, so ferrite core, wire wrapped around it, 2 terminals. Your voltage control, there's looks like a small adjustment trimmer. We got 3 poly dip caps. Looks like a transistor, 1, 2, 3, 4 resistors, and looks like a diode, little blue diode down there. So not a lot to it. So you have the rib cord right there, so that's the neutral, and then this blue wire then supplies the neutral back down to the switch for the illumination, because you have to have a return path so that light can light up. So that's why there's a neutral going back down there. The brown wire is going to be your hot coming up to the board. So yeah, they go to this little transformer, and there's 2 terminals on the back side. It's the hot side. So there's basically like a ground reference resistor, and looks like that does have a green band. So yeah, it's a really high value resistor, but it goes basically between the hot and the neutral. And the bypass cap's attached to neutral on one side and the hot on the opposite side, or the output of that transformer. So that's what that filter cap is across. But what is... That doesn't make any damn sense. What the hell? I don't know if you're seeing what I'm seeing, but there's a blob of solder right there. That just... you can see this board, I'm sure it was wave soldered. So, all the components were stuffed in it, went through a wave soldering machine, and then it was cleaned. And there's no solder flux. But you see all that? Somebody came in here after it was made and put a blob of solder right here. Well, where is that blob of solder? It's across both the terminals of that inductor, or that coil. What the hell? Why did they do that? Did they find that coil was burning out? I mean, I don't know. I didn't make this thing, but yeah. Was it underrated? Not heavy enough? Because, yeah, the power is going to go through that, and, well, it's not now, because they have it bridged with solder, but here's the 1 pin for the transformer, comes out, and then to the handpiece, and then the other one's going to be, here's the other side of the output of that transformer. Remember the resistor, the capacitor, and then it's supposed to go through that coil and then to the voltage regulation circuit. Yeah, they bypassed it, so I don't know. And I mean, that's actually going to be, why would you even put it in there if you're going to bodge across? Because, shoot, that's going to be, if you think about it, that's probably one of the two most expensive parts in here, the coils. Coils usually are actually, in transformers, are rather expensive in the grand scheme of things. I mean, considering the price of the other parts that are on this board, why would you bother installing it? Maybe they found out, after they've been making these things, maybe they had a bunch of people sending them back because they stopped working and it was the coils were burning up. So, yeah, they just bodged, they took the ones they already had made and just bodged across with solder. But, yeah, that's definitely after the fact. Yeah, that's kind of concerning. Why wouldn't you? You're going to take your coil out. So, yeah, and it just dawned on me, there's no protection on this thing. There's no fuse, there's no PTC, there's nothing here. So if anything happens here, smoke's going to come out. Another reason they might have done that was burning up. Yeah, there's no fuse. There's no circuit protect. Now, granted, honestly, that's not completely uncommon in cheap electronics. But personally, yeah, I'd like to see a fuse of some sort in this thing. Be it a little surface mount fuse, or not surface mount, but a pigtail fuse just mounted to the board or something. But just a little pico fuse. But yeah, the quality seems it's about what you'd expect for the price. It works, but yeah, that's got me. Yeah, I don't know. I've got mixed feelings about this unit now. No circuit protection, and parts bodged over. So, yeah, why not just respin the board? It's not like this board costs much. Especially if you're building these things in mass quantity, it's not going to cost that much to. And if that coil was burning up because it's not heavy enough, put the proper size coil in it. Get one that's rated for higher current. Don't just eliminate it by jumping across it. Yeah, that's half-assed. So, the fuse part, actually, that's, because this mounts like that. I think you'd actually have enough room. Just want to see here. Yeah, you could, and it sits flush there. Yeah, it doesn't really stick down past the bottom. You've got enough room on the sides or even the back corner here. If you were so inclined, let me grab one. Let's see, fuse holders. This style, the little small ones. But yeah, you could just stick a fuse holder, drill a hole in the side, stick a fuse holder in there. That way it's accessible from the outside. Yeah, it'd be easy to do. Just disconnect the wire off of the switch, the hot wire, run it to the fuse, and then from the fuse over to the switch. Yeah, I'd like to see a fuse or something in there. But yeah, that's between the no circuit protection in that bodge. Honestly, I got mixed feelings about this thing. So, there you go. That's my review. From the outside, using it, safety on the outside. Like I say, checked it for leakage current. It was fine. I mean, shoot, this has less leakage current than a lot of test equipment that I see. But inside, yeah, I'm kind of it's questionable. For the price, I guess it's about what you'd expect. But that just, yeah, that's a big red flag for me. If you were having problems, fix it. Don't bypass the problem. So, yeah, I kind of got mixed feelings about this little guy. So there's my review of the Dr. Meter model Si-48. And they do say it's ROHS compliant. I'm not going to go testing it to see if it is, but yeah, do not throw away whatever the heck that says. TUV Rhineland, so maybe that's a German specification. It says US, but yeah, I don't know. I don't think that's supposed to mean US as United States. That might just be a code, because there's no CE or UL listings on here. So, but yeah, So, questionable. That's probably how I would rate this. Works just fine. Good thermal reserve. Soldering iron seems safe. Very low leakage current. But the controller is questionable. Yeah. There's my review. So, I hope that helps somebody with their decision on whether to buy one of these or not.